I am Anil Kumar. Welcome to my series on algebra. We'll discuss some distance, speed, time, word problems in this particular video. Let me thank all the viewers and subscribers for their comments, and especially those who have requested this particular example. I'm actually translating one of my videos in Hindi for him in English. I've added few questions to make it more interesting. Now let us see what we are going to understand in this particular video. We'll actually understand basic concepts to work with distance, speed, time word problems. We'll also see, which is new in this section, about reading graph and finding meanings from the particular graph. We'll learn a shortcut method to solve multiple choice questions. We'll have 7 examples to practice, and that is your formula: distance, speed, time relation. If you have any questions, you can always contact me on my email anil.anilkhandelwal@gmail.com. Let us first have a look at the type of questions we have. So we'll begin with very simple question relating distance, speed and time. And then in question number 2, we'll actually derive the most important formula which is going to be applied in 4 of our questions to solve multiple choice questions. So these are the multiple choice questions which we are going to take. Now if you solve these 4 questions, then you should be in a position to answer most of the questions related to distance, speed and time. Perfect. So I'm actually just going through these questions in no particular order, and then we'll take them one by one to solve. You could actually pause the video in between, solve them, and then look into my suggestions, right? What you notice in these questions is that we're talking about distance being covered at different speed, and so there will be different time. And sometimes we'll be finding the time, sometimes the distance, okay? So, and that is the 7th question which I was talking about, which is again covering some distance and relating them with speed and time. The last question is the graph which we'll try to understand. So I hope you find this interesting and useful. So let's begin with the very basic concept. Okay. So what you need to concentrate here is on the formula itself. This triangle indicates the relation between distance, speed and time. You can write distance is equal to speed into time, right? If you want to find speed or time, you can say speed is equal to distance over time. And you can also write time as distance over speed. So that is how they are all related. Perfect. Now let's move forward and answer questions one by one. Question number 1. It says, it takes me total of 5 hours if I walk to the school at 2 kilometers per hour and return at 3 kilometers per hour. Find the distance of the school. So what you notice here is that we have 2 different timings, right? So walking towards and then returning. Distance is same, right? So in this case, we have same distance. The only thing here is that it takes me total of 5 hours, right? So the total time is given to us, which is 5 hours, right? Now, while going away, I walk to the school at 2 kilometers per hour. My speed is 2 kilometers per hour. So I'll write that speed as S1, right? So I'll use 1 and 2 subscripts to describe. So I'm writing speed S1 as 2 kilometers per hour. And return at, that is the second speed, S2 at 3 kilometers per hour. So those are my speeds, right? Now what am I saying? I'm saying that the total time taken is 5 hours, right? Now again, look into our triangle of distance, speed and time. We know distance is product of speed and time, but in this case, the focus is on time, right? So since we are given total time, the focus is on time. That is important to understand. So we will see what time is. So time is equal to distance over speed. So that is the major formula which is going to be applied. Does it make sense to you, right? So it takes me total of 5 hours. That means going in this direction, time t1, coming in this direction, time t2. Sum of these two times is 5 hours, right? So what we are given here is that t1 plus t2 is equal to 5. That is what is given to us. Now we know time is ratio of distance and speed. So for going, distance is d, right? So d over 2 kilometers per hour plus returning d over 3 kilometers per hour. That should be equal to 5. Does make sense to you? So simple as that, correct? Now, it is like fractions. We can take a common denominator, which is 6 for us, multiply, cross multiply. So 3d plus 2d equals to 5. So now we can cross multiply. This is 5d. So we can write 5d over 6 is equal to 5. Correct? Now it's very easy to simplify and get our answer. What do we need? In this question, we want to find the distance, right? So let me rewrite this for you. Here we have 5d over 6 equals to 5. So distance is 5 times 6 over 5. So these 5s, they cancel, right? You're left with 6. So distance is equal to 6. What are the units? Most important is to add units. We know we're talking about kilometers per hour. So the units are kilometers. So we have our answer here that the distance is 6 kilometers from school to home or home to school, right? So when I am saying it takes me total of 5 hours, so we're walking to the school, right? So we'll assume that we started from home. Anyway, it could be any other point, but from that point to the school, the distance is 6 kilometers hour, right? Now, it's a good idea. This is our first example. We will also try to check our answer, right? It is not always necessary, but it's kind of good to check. So, if that is the distance, let's say this is 6 kilometers, right? We are walking with the speed of 2 kilometers per hour. So first distance is 6 divided by 2, which takes us 3 hours. On returning, 6 divided by the speed is 3 now. It takes us 2 hours. And when you add them, we do get 5 hours. So that is perfectly fine. Do you understand the basic concept, right? So this example may be the simplest of all, but it explains you almost everything you need to know to solve rest of the questions. Perfect. Now let's move on to question number 2. Question number 2. I walk at an average rate of x kilometers per hour to the office and return at the speed of y kilometers per hour. If the return time is more by t hours, find the distance to the office. Now here, we will actually derive a general formula, right? So this is the most important part of the video. So we are going to derive general formula, which could be used for a shortcut solutions to a multiple choice questions. We'll after this take up multiple choice question and see how we can immediately solve most of the multiple choice questions, okay? So it says I'm walking at an average speed. So whenever we have some speed and all, we'll take S1, T1, D1 as our case, right? So I walk at an average speed of x kilometer per hour. So my speed here is x in this direction to the office and return at, so when I'm returning, that is my return, same distance, I return at y kilometers per hour. Both are in kilometers per hour, right? Okay. If the return time is more by t hours, let's say this time is t1, this time is t2, then it says return time is more by t hours. That is to say, we are saying t2 minus t1 is t hours. So that means you are walking slower. and therefore you took more time. Perfect? Clear? Now, in this particular case, the distance is same. So d is the distance for both the cases. Perfect? Also, you remember that the formula which relates distance, speed and time is what? Is distance is product of speed and time. And what is critical thing here? Time is critical, since we are saying if the return time is more by t hours, so our time is critical. So we are going to use this formula in the form of time is distance over speed. Does it make sense? Right? That relates each and everything. Now let's see. So this is our strategy. Whatever we are talking on the right hand side, we are only trying to understand the situation. Perfect? Now once we understand, we can immediately solve it. So we are taking more time to return. So whenever you want to subtract, it is better to do return over going. Perfect? So distance is d. So basically we are saying t2 minus t1 is time t. Time to return is distance divided by speed. To go, it is the same distance by x, and time is t. Perfect. We need to find what distance is. So we'll take a common denominator, which is product of x and y, cross multiply. So we get d times x minus d times y equals to t. Then we are going to cross multiply, take d common, right? So we get d within brackets x minus y equals to t times x times y. Perfect. So what is the distance equals to? Distance is time times product of x and y and their difference. Does it make sense? So what have we got here? We have a general formula to solve. So if you have a situation in which we are given two different speeds for the same distance. So for same distance, different time, you can use this formula that distance d is equal to time t, right? That is a difference in time t. And here we have product of these two, x and y, and here we have difference, right? So to translate, we can say distance is equal to difference in time times product of speeds over difference in speed. Does it make sense? Now, sometimes you may actually put it on the other side, right? Wrong way. You could do it. But remember, distance is always positive. Does it make sense? So you can take the absolute value. Do you understand? Take positive value. Suppose if you interchange it, not a big deal. Distance has to be positive. Remember that. Perfect. So what we learn here is that for a constant distance, it is always equal to product of time, the two speeds, divided by difference in speed. Does make sense, right? Let's take an example and then see. Question number 3. It says, two cars travel from city A to B at a speed of 30 and 36 kilometers per hour. So from A to B, we have this point A. This point is B for us. One car goes at 30 kilometers per hour. The other one at 36 kilometers per hour. If the car takes 3 hours less, if one car, so obviously the faster car will take 3 hours less. So we know change in time is 3 hours less, right? That is less. Then the other car for the journey, then the distance between A and B is what? So shortcut formula says distance should be this time 3 multiplied by 30 multiplied by 36 divided by the difference, which is 36 minus 30. That is your answer. Do you get it? That is the shortcut answer. So immediately you can write this as 3 times 30 times 36. Their difference is 6, right? So that cancels 2 times, and this cut this away, 18. So 30 times 18, which is equal to what? 10, right? 3 times 8 is 24, and 540 kilometers is my answer. Do you see that part? So multiply all three, divide by the difference, get your answer. So that is a quick solution, and that is going to really help you to answer multiple choice question, right? Now let's get back to the real solution, which is for our benefit to understand. So what we are saying here is that the distance is d, and the difference of time in this case is 3 hours, right? So d divided by 30, right, which is going to be a bigger number, 30 or 36? 30, right? Divide by 30 minus d divided by 36 is equal to 3 hours. That difference is 3 hours, right? It takes 3 hours less. 3 hours less, that is the difference. So we are saying T1 minus T2 is 3 hours. Got it? How will you solve it? Just as we did earlier. Common denominator of, I'm writing both, okay? I know you could write some other number, but don't bother. And then we can take d common. 36 minus 30 equals to 3. So what is d equals to? D is 3 times 30 times 36 divided by this difference, 36 minus 30. Does it make sense? Same thing, right? And you get your answer as 540. Perfect? I hope that is clear. Now apply your strategy in the next question, and that is the reason why I have taken these questions, one after the other. Question number 4. A student goes to school at a rate of 2.5 kilometers per hour, okay, and reaches 6 minutes late, okay, 6 minutes late. If he travels at the speed of 3 kilometers per hour, he is 10 minutes early. So if he goes at 3 kilometers per hour, right, 3 kilometers per hour, then it is 10 minutes early. What is the distance between the point and the school? Well, what should you do now? I have not given you a particular time, but I have given you 2 times. 6 minutes late and 10 minutes early. So what is the difference? Difference is 10 minus minus 6, right? 10 minus minus 6, which is 16 minutes. Now, our units are in kilometers per hour. So I should convert this to hours, right? So we'll say 16 over 60 hours. Does it make sense? So 16 minutes, convert them to hours, right? So when you convert them to hours, you get what? You get 16 over 60. Now you could multiply, divide both by 4. So you could say this is 4 over 15 hours. Does it make sense? Correct. Now, do you want to apply a shortcut method to find the answer first? And then we'll do the real solution? Let's do it. So we want to find the distance d, which should be product of all three, which is 4 over 15 times 2.5. Okay, so let's write in fraction. 2.5 means 5 over 2, right? So 5 over 2 and 3 divided by difference between 2.5 and 3, right? Which is half. Is it okay? That is our answer. Why did I write in fractions? Some of you are very afraid of fractions, but they help. See, you could cancel this by 2, you could cancel this by 5, and this 5 and 5 cancel. So clearly you get 2 times 2. This comes up, right? And the answer is 4. So we get our answer as A, 4. Do you see that work which we just did? That's the beauty. Perfect. Now let's do our standard method and understand how we got all this. Shortcut method, right? It's very effective. So what we realize here is that slower speed means more time. So d divided by less speed minus d divided by more speed is 4 over 15. It is important to do this conversion. Very important, right? So make a note of this. You should not be using minutes when we are working with kilometers per hour. Is it okay? Now you just cross multiply as we did earlier. So we get 2.5 times 3. And here d times 3 minus 2.5 equals to 4 over 15. So d equals to 4 times 3 times 2.5 over, this difference is 0.5 times 15, correct? You could do like this. And then cancel. 0.5 goes 5 times, right? 5 times. And this 5 goes 3 times. And this 3 goes and you're left with 4. So working with decimal was not a bad idea. Okay, so I hope that makes sense, correct? So in this particular case, even decimals worked fairly well, but get into the habit of working with fractions. It helps, okay? Question number 5. To travel 816 kilometer, an express train takes 9 hours more than Rajdhani. If, however, the speed of the express train is doubled, it takes 4 hours less than Rajdhani. What is the speed of Rajdhani? 4 choices are given to you. Now this question actually is the most difficult question in this set of videos. Now, I would like you to pause the video, try to answer this question and then look into my suggestion. And you'll really love the trick with which I am going to solve this question. Okay. Now again, what is critical here? Is it speed or time? That is a very important question, right? To travel 816 kilometer, an express train takes 9 hours more. So we are talking still about the time. Right? We may have to find speed, right? But it is critical. Time is very critical. If you could observe this, then see how we can solve the question very easily, right? Now let's read again. It says, to travel 816 kilometer, an express train takes 9 hours more than Rajdhani, another kind of train. If, however, speed of express train is doubled, so if speed is doubled, then time will be what? Reduced to half for the same distance, right? Since the distance is fixed for the same distance. Does make sense? Which is for us 816 kilometers. Do you get it? Since the distance is 816 kilometers. Now see how we will actually move forward and solve. So instead of writing that let the speed of the two trains be x and y, we'll say let the time. So let's say let the time t of the express train, we are saying time of express train. So it says to travel 816 kilometer, an express train takes 9 hours more than Rajdhani. So TE, time for express train, is more by that of Rajdhani by 9 hours. Perfect. The second sentence is, if, however, speed of express train is double, that means this time is half, right? That means this time is half. If, however, the speed of express train is double, then this time will be half. It takes 4 hours less. So then the difference between these two is minus 4 hours. Does it make sense? 4 hours less. Correct? So we get two equations. Do you agree with me? Now, we need to find what is the speed of Rajdhani. So we have two equations. I could take away, cancel the time for Rajdhani, get it in terms of express train, and then do some more calculations and find R. Well, I won't do that. I want the time for Rajdhani since I need speed of Rajdhani. You get the idea, right? So what am I going to do here? I am going to multiply this equation by 2 so that I get this also in terms of TE minus 2 times TR equals to minus 8 hours. Does it make sense to you? Minus 8 hours, right? Time is in hours for us, correct? Now, I will do, this is my equation number 1, the first one. This is my equation number 2. What should I do? I don't want these times, so I'll do equation 1, take away equation 2. Correct? So when I take away, these cancel, and here I get time for Rajdhani, right? 1 minus 2, that becomes negative. And here, 9 plus 8 becomes 17. So we know time taken is 17 hours. So if time is 17, what is the speed? If time is 17, what is the speed? It is easy to calculate, correct? We know distance is relative with speed and time. We want speed. So speed will be equal to distance over time. Distance is 816 kilometers and time is 17 hours. So we get our answer. You may have to divide or you can estimate, right? You can estimate and you'll get your answer. These numbers are far away. This is around 50, this is 60, this is 30, this is 70 approximately, right? So this 17 will go approximately 50 times. So you get A as your answer. If you're not ready to do so, you could divide 816 divided by 17. So you get 4 times. 4 times 7 is 28, 2. And 4 times 1, 4 and 1, 6. And when you take away this 3 and 1, right? This is less than 17, but very close. So it is a high number. So A matches. Do you see that? So slightly less than 50 if you estimate. But without calculator, this is the best way to solve the given question. So I'd like you to actually pause the video. Try to do it once again, understand what we have done here, and then move on to the next question. Okay? Question number 6. A journey of 600 kilometers takes 30 minutes longer when the speed of the airplane is decreased by 200 kilometers per hour. Find the normal speed of plane. 4 choices are given to you. Now in this case, can you use our formula which we derived? The formula was, let's remind, distance equals to time difference times speed 1 times speed 2 divided by speed 1 minus speed 2, right? That was the formula. Can you use that formula to solve this question? That is a big question. If you can really kill this multiple choice question. Let us see how. So distance is 600 kilometers, right? So we get 600 kilometers. 30 minutes. 30 minutes means what? 30 minutes means half hour. Or 0.5 hours, right? So time difference is 0.5. Let me write 0.5 here. Or you can write half. Speed. It says when the speed of the plane is decreased by 200. So let's say speed is s. Then the other speed is s minus 200. Is that clear to you? So one speed will be s, the other will be s minus 200. And the denominator, we have s minus 200. Does it make sense? We have applied the formula. Now, let's calculate. So, you will notice that what we have here is half. If you would have written fractions, it was actually simpler, but I'll keep half. We have half of s times s minus 200, and in the denominator, s minus s is 0, minus and minus makes it plus 200. Perfect? Which is kind of like this. If this was half, half is better to work with. We get s minus 200 times s over, this is half, right? So this becomes 400 here, right? 0.5 is half. So it becomes 400. Is that okay? Now if you cross multiply, we get 600 times 400 is equal to s times s minus 200. Now, if you compare, what is the solution? 600, 400. 400 is 600 minus 200, right? That means s should be equal to 600. Perfect? So the answer is C. Did you see how, with the help of our formula, we actually solved this question without any problems? If you don't want to use it, you can still work. We have 600, the distance, divided by slower speed, s minus 200, correct? And the difference with 600 over s should be equal to half. So in this equation, s is the only unknown. You could solve this equation, and after you solve, you'll get this kind of an equation, then get your answer. All right? So substitute values you'll get from here to this place, since we derived the same formula, and then you can get the answer. Does it make sense to you? Have a good look at it. So in question number 5 and 6, we have jumped a level, and we are now really working towards some serious problems with distance, speed, and time, where difference of time and now difference of speed is given to us. So I hope the concept is clear. So that formula can actually be applied in all such situations. Perfect? Now let's take general questions based on distance, speed, and time. Question number 7. Anil drives a distance of 50 miles along a highway from A to C. Right? So this is A, this is C, and this is 50 miles. The first half of the journey, that means right midway, we have another point B, right? The first half of the journey was at an average speed of 50 miles per hour. So there, the rate is 50. And the later was at an average speed of 60 miles per hour. So everything in miles per hour. Is it okay? Makes sense? Find the difference in time to the nearest minute between the two parts of the journey. Straightforward, simple question to end, right? So how do we do that? So what is time 1? Well, the distance here should be how much? Half of 50, which is 25 miles. And here the distance is also 25 miles. Time, as we know, is distance divided by speed. So time for the first leg is 25 divided by 50, or half an hour, right? We have to write answers nearest to minute. So half an hour means 30 minutes. Clear? Second part. Again, second time is distance of 25 divided by speed of 60. Now fractions. We'll just divide by 5. So get 5 over what? So 5 goes 1 times 12. Right? So we get so many hours. Fortunately, we have to write with minutes. So I will write 5 over 12 multiply by 60 to get minutes. Do you see? So that becomes simpler. So 12 goes 5 times. Oh, I get 25 minutes. Beautiful. So the difference in time is how much? 25 and 30. Difference is 5 minutes. Do you see that? So without calculator, easily we could solve this question. Simple logic. The formula, distance, speed and time, helped us to get this question. Perfect. Now let's look into the last question, which is slightly different from whatever we have done so far. And these two were in addition to what we had earlier in our video. Okay. I hope we have really mastered few strategies. Right? Now, we'll see how to read a graph. This is the distance versus time graph. Small print. Distance is given along the y-axis in meters, time along x-axis in seconds. Explain the distance versus time graph and determine total distance traveled, average speed, maximum speed, displacement, interval for object moving away. Perfect? Those are the questions. Now, so it is object moving away. So we'll take an object. So let us say the object, how will you describe? So object starts at a distance of 6 meters from somewhere, right? So this is our position O, let's say, right? So let us say from the source, right? So we'll call this as our source, right? So source actually is anil.Khandelwal. So you can always email me for any doubts. But let's now describe this. So what does it say? So we can say that the object, we'll write here, object starts 6 meters away from source, right? So that is the initial position, right? So this is our initial position. Clear? And then what happens? Then it moves towards the source, right? Then it moves towards. Why? You see the distance is decreasing. The distance decreased from 6 to 4. Perfect. It moves towards. Now when it moves towards, at this time, we can actually find the speed also, right? So speed is rise over run. So look into this triangle. So it is going down by 2 and this time is also 2, right? So this is 2, this is 2. So we can say moves towards source at the rate of 2 divided by 2, 1 meter per second. Does it make sense? So we found the velocity also in this, right? Which is ratio of rise over run. So V1 velocity is distance of 2 divided by 2, so 1 meters per second. Is that okay? Then at B what happens? After, which is at 2 seconds, right? So we can say after 2 seconds. After 2 seconds, it speeds up. Why? Since it is steeper. So what do you notice here? That the graph is steeper. So it speeds up, steeper. So I am saying speeds up. Now what is the speed in this interval? Well, you came down from 4 to 3, which is a distance of 3 in 1. So it is velocity 2. Here is 3 meters per second. Do you understand? So it speeds up. So after 2 seconds, it speeds up to 3 meters per second. 3 meters per second, right? For 1 second. For 1 second. So this is speeding up just for 1 second. And then what happens at C? At C, it is not moving. Do you see that? This portion is stationary, not moving. So object is stationary. That you could say it rests for 1 second, right? 1 second, and then And then what? And then moves away. Why are we saying moving away? Because now the distance is increasing. Because in this part, increasing distance means moving away. Does it make sense? Increasing distance means moving away. Now it's a good practice to find the speed once again, right? So what could be the speed? So it is a stationary, straight line, so we can find the slope. So it went away from 1 to which point? It seems it went back to 6, right? So, okay, we'll assume this to be 6, okay? 6. So it went 5 up in 1, 2, 3 seconds. 1, 2, 3 seconds. So 5 over 3. Do you see that? So it moves away at the rate, or you can say velocity or speed, at speed of 5 over 3 meters per second. Then what happens? Then reaches 6 meters away from the source. So that could be a description for you. There are many ways to describe it. Perfect. Now, that is the first part, very important. So what you notice here is that we actually found in different intervals the speed. So if you don't find speed, you actually lose communication marks here, right? So very important. So find speed in each interval. Critical. Now let us answer these questions. First question is total distance traveled. How will you find this? Well, the object started 6 meters away, came down how much? 5 units. Do you see that 5 meters? And then it finally went 5 meters. So total distance is 5 plus 5, which is 10 meters. Perfect. So don't get fooled by 6 and 0. It never touched 0. It came down 1 meter away, started 6 meters away and landed up 6 meters away. You get an idea, right? So the total distance is only 10 meters. So that is your answer for the first part. Second, average speed. Average speed is distance over time. So the distance is 10 divided by the time taken. We are working with 7 seconds, right? 0 to 7 seconds. So we'll divide by 7 and that is your meters per second. 10 divided by 7 meters per second is your average speed. You have to include the time when the object was at rest also. Perfect? Now, maximum speed. For maximum speed, you need to check the rate. It doesn't matter whether it is coming down or going up. So in this case, we figure out that the maximum speed was at this time. So we figure out that the maximum speed was when it was approaching from B to C. You don't have to bother about negative or positive. Speed does not have any sign. We're not saying velocity, right? Speed is a scalar quantity. So you have to see the magnitude. 3 is maximum. So the maximum speed was 3 meters per second. Is that clear to you, right? Displacement. Now displacement is a technical word which means change, right? It started from 6 meters away and landed 6 meters away. So in this case, what is the displacement? Well, the displacement is 0 meters. Since it started from 6 and ended at 6, do you see that? So displacement is 0 meters. Second, last question here is interval for object moving away. So it moves away from D to E, right? That is the position. And as far as the time interval is concerned, it is from 4 to 7. So we'll write from 4 seconds to 7 seconds moved away. Is that clear to you? Perfect. So that is how we are going to understand the graph, describe the graph, and write all the parameters related to it. So I hope that really helps. Feel free to contact me in case you need to. email addresses given here, and I hope you enjoyed as much as I enjoyed sharing with you the solution of these questions along with some beautiful tricks. Thank you and all the best.